On this week's very special April 1st, 2019 MetPy Monday, we're going to finish up our pilot report parsing by pulling out turbulence data and making a plot of turbulence over the U.S. right now. Welcome to another MetPy Monday. Happy April Fool's Day from all of us at Unidata and the MetPy team. So to go ahead and pick up where we left off, I've condensed our notebook last week a little bit and made one important correction. I moved this report rows, where we're finding all table row elements in the HTML, into our parse report function. We had it outside of the function last week, but we need to go ahead and move it inside for a little bit better encapsulation and to put all of the functionality that's actually doing the report parsing in that function. So to review where we are, we're using URLlib and Beautiful Soup. We wrote this function parse report that you can learn all about in last week's MetPy Monday. And that takes the HTML and creates a dictionary that represents a single pilot report. We requested data. This is back from week 1 of this series. And then we used a list comprehension to make a list of dictionaries. So this calls the parsed report function on every single pilot report. So now let's go ahead and look at reports. So this is a list of dictionaries, just as we expected. You can see that there are keys like turbulence, latitude, longitude. So what we're going to need to do the plotting is latitude, longitude, and the turbulence string. But we need to do some manipulation on that. We can't plot based on a string. So we need to know what kinds of turbulence are reported. What are the possible values here? So to do that, let's print out the turbulence, if it is in a report, for each of these reports. So for report, in reports, if report.get turbulence, print report turbulence. So if you're not familiar, .get on a dictionary will return none if that key is not in the dictionary. So this should only print the turbulence value from reports that have turbulence. So we're getting things like continuous moderate chop, light to moderate chop, light to moderate, occasional light moderate, negative, light, moderate clear air. So there's a lot of continuous low-level wind shear, occasional light to moderate. There's a lot of different vocabulary going on here. And so we have to make some decisions about how we're going to parse that. I'm going to parse it to where we grab the most severe value out of a string. So if it says light to moderate, I want to get moderate. Continuous light to moderate, I want moderate. That will give us the sort of worst case scenario turbulence map here. Let's go ahead and remove that cell. So to do this, we're going to need latitude, longitude, and turbulence severity, which we're going to use an integer for, something that we can do numerical things to. So I'm going to create 3 lists to hold these information. You could do this in a number of ways. Again, this is just how I've chosen to do it here. I'm going to create a lats, a longs, and a severities list, and they're going to be empty. Now we're going to loop through each report, so just like we did for report and reports, if report.get turbulence. So again, if there's a turbulence report in the pilot report, then we will go ahead and process this if block. lats.append report.get latitude. Now you might say, why are you using .get instead of the square bracket notation? Well, suppose we have a malformed report that does not have latitude in it. This would just append none, and we would go on and we would have improper plotting. If we use the square bracket notation and that key is not there, it would result in an error and our program would crash. So this is a little bit of a safeguard against things like that. So lons, we're going to append longitude. And now I'm going to parse the turbulence string. So the first thing I'm going to do is pull out the report into a variable called turbulence. And the capitalization is not important to us, so I'm going to call it .lower. This makes everything in the string lowercase, and it's going to make doing comparisons a lot easier. So if you are doing something that takes user input, very often we want to go ahead and force it to entirely uppercase or entirely lowercase so that our program has to handle fewer permutations of what the user could have typed. And since we want to start with the most severe, and if it's moderate or light to moderate, we only want to record moderate, I'm going to write this if, elif, and else block such that it starts out with the most severe. So if severe in turbulence, then we're going to append 3 to our severities list. Elif moderate in turbulence, we'll append 2. If light, we'll append 1. And otherwise, we'll assume that it means no turbulence. If none of those are in there, then we'll assume that this report has inconsequential turbulence. So we'll append 0. The reason I chose this sort of flow control structure is these are all mutually exclusive. So if they're severe, this is the only thing that happens, and then we go on to the next thing in our program. Otherwise, moderate, and then we go on to the next thing in our program, and so on. We can't have more than one of these run. For example, if I had all of these as ifs, light to moderate would result in 2 values getting appended to my severities list. And then we would have different list lengths, and it wouldn't be a great thing. So these if, elif, else flow control structures can be really useful for things like this. So we're going to go ahead and run that. And that has parsed everything out that we need. So now we just need to create our map. To do that, we're going to need some imports. So import matplotlib.pyplot as plt. Import cartopy.crs as ccrs. Import cartopy.feature as cfeature. Then we're going to use our matplotlib inline magic. If you need a refresher on plotting with Cartopy, we have several videos that do that, and I would encourage you to go back and take a look at those. So first I'm going to create a figure. In my case, I'm going to set a fig size of 20 by 10. I'm going to create an axis. 1 row, 1 column, first plot. And then we need to specify a projection. In this case, I am going to plot on one of my favorite projections, the Lambert conformal. So remember, this is the projection of the map, not of the data, but of the map that we want to plot. Now we're going to plot our data. For now, I'm just going to plot lawns and lats, and let's make sure we get data plotting on the map that looks right. Then we'll make it a little fancier. We do need to specify a transform, since our data are in a different coordinate system than our map. Our data are lat and lon values, which are called Pt.3, which we always joke is French for I don't have a projection. It just means latitude and longitude values. I'm going to go ahead and add a couple of features so we can see if we're on the right track. So cFeature.coastline and states. So we know that most of the aircraft are going to be over the continental United States. So if we plot that, we see there's not a lot of turbulence reports this morning. And a lot over here on the East Coast comparatively, but this seems reasonable. I see a little bit of traffic around the hubs, some activity on around the mountains out here. So now let's use that severity information and color the dots by the severity. We do that by adding the keyword argument C equals, and then what we want to color the dots by. So by default, it's using the Viridis color map, but I want to change it to something that's a little bit more purpose suited. So oranges is what I'm going to use. And I'm going to specify that the edge colors are black so that each dot has a black outline. That way the light colored dots are a little bit more visible. So now we can see we've got very light turbulence reports here, getting more severe as we get towards the coast, and some pretty severe turbulence reports out here along the front range of the Rockies, which makes sense. But this is overall a pretty quiet map. I would encourage you to run this again on a different day when we have a big trough pulling through, and you can really see some nice patterns in the pilot turbulence reports. It's also a handy utility if you're going to be flying somewhere. You can make a quick plot and see what to expect along the way. I hope that you found this useful, and I'll see you on next week's MetPy Monday.